Hello, today we will continue with probability. As you're aware, this is an approach we will take with the flipped classroom as part of the Leaving Certificate Mathematics curriculum. So just a very brief recap on what we've covered so far. Firstly, probability is a study of chance or likelihood. We looked at the probability concepts such as trial, outcome, sample space and event. And we also used the likelihood scale and a probability scale. If you're not sure or unfamiliar with any of these concepts, please look at the first video. Just want you to look at this coin here. And something a lot of learners brought up, they asked the question is, what is a fair-sided coin? Well, a fair-sided coin has a head and tail on both sides. However, if you have a head on both sides, then you cannot possibly get a tail. Therefore, in this case, it's a trick coin, which would also be an unfair coin. So these are some of the most common resources that are used in probability, such as a deck of cards. There you have 52 cards, 13 hearts, 13 diamonds, 13 clubs and 13 spades. So for example, if I asked you, what is the probability of getting a red? Well, you've 26 red cards there out of 52. You can simplify that to 1 over 2. Again, with a dice, and just remember the plural of dice is die. So if you have just say 1 dice, there are 6 outcomes there, 1, 2, 3, 4, 5 or 6. And the bottom right there you have what's called a spinner. And now if you look at the spinner, you have 2 outcomes of a 1, of a 2 and a 3 and so on. But these are some resources that you'll have to understand in order to completely grasp what probability is about. So the learning objectives for this lesson will be to know the meaning of relative frequency, able to calculate relative frequency, know the meaning of expected frequency, and finally able to calculate expected frequency. This brings us to relative frequency. In the vast majority of events, it's difficult to predict the outcome of an event, and for this reason we use trials or experiments. And with this can give us then the relative frequency, or what's called the experimental probability. Relative frequency is an estimate of the probability of an event. So relative frequency is equal to the frequency of an event out of the total number of trials. So what we're going to do here is we'll show a spinner, okay, and we'll first get the tally, get the frequency, and then get the relative frequency. Okay, so the total number of trials we will have is 10. Okay, so let's come here and we just spin the spinner here, and we can see the first one that we get is a 1. Okay, so if I come back in here, so just there's a little dash like that, just to illustrate that that's 1. Okay, spin again. Now I have a 4. I had there for a 4. That's 2 we've done so far. A 3. A 6. That's our second 3 we've got. So 1, 3, 4, 5, we're halfway there. 2. Okay, finally get a, oh sorry, that's our second one. Okay, we had a 1 already. 2. Okay, let's check 2, 4, 6, 7, 8. 2 more spins. 6. And this is our last one now. Let's just spin. We get a 5. We don't. We get a 3. Okay, so I can add these up so that the tally there is 2. So the frequency that is 2. That's 2 as well. That's 3, 1, 0, and 2. So to get the relative frequency then, what you'll do is you get the total number of trials. All of these, by the way, should add up to 10. So 2, 4, 7, 8, 10. That's great. So it's all out of 10. So this is the frequency here. Relative frequency for the number 1 is 2 out of 10, which I can simplify to 1 over 5. This is the same as well, 2 over 10. That's a 1 and 5. That's going to be 3 out of 10. I can't simplify that any further. 3 out of 10. That's going to be 1 out of 10. 0, which is equal to 0. 2 out of 10, which is equal to 1 out of 5. And then if you wanted to, sometimes you might have to change these decimal places. So that's 0 0.2, 0 0.2, 0 0.3, 0 0.1, 0, and 0 0.2. And with relative frequency, they always should have to 1. So that's 0.2, 0.4, 0.7, 0.8. That's equal to 1.0 is a total. That's how to do a relative frequency table. So it's important to distinguish between theoretical probability and expected frequency. So for example, if you're flipping a coin, you would expect theoretically to get a 50-50 chance, 1 and 2, or 50-50. However, if you had a trial and just say you flipped the coin 10 times, you could end up with 7 heads or 3 tails. So obviously there's a difference there. But what is important to note is that as the number of trials are increased, the relative frequency will converge, will move towards the theoretical probability of the event. So in this case, you might start off with 0.7 and 0.3, but as the more trials increase, it will eventually move to 0.6, 0.4, 0.55, 0.45, and eventually it will move towards the theoretical probability. So expected frequency. With expected frequency, we can estimate how many times an event would be expected to happen over a certain amount of trials. The formula for this is expected frequency equals number of trials multiplied by the relative frequency or theoretical frequency. So a fair dial is rolled 300 times. How many times do you expect to get a 2? Well, the probability of getting a 2 firstly is, so probability of getting a 2 is equal to 1 over 6, and this you multiply by the number of trials, which would be 300. Let's go 300 over 1. Therefore that is equal to 300. 300 by 1 is 1, divided by 6, which is equal to 50. So you can expect, if you roll the fair die 300 times, you will get a 2 50 times. A coin is flipped 50 times. How many times would you expect to get a tail? So again, the probability of getting a tail is equal to 1 over 2. And if you did it by 50 times, or 50 trials, 50 by 1 is 50, 2 by 1 is 2, and if you simplify that then it's 25. So this is your expected frequency. So again, just to recap, if you roll the fair die 300 times, your expected frequency to get a 2 would be 50. And if you flipped a coin 50 times, your expected frequency for a tail would be 25. So this concludes the asynchronous lesson of relative frequency as part of the probability flipped classroom. So just some homework. Apply your understanding of relative frequency and complete questions 1 to 7 on page 319 in your textbook, and create an example yourself where an expected frequency of an event would converge to theoretical probability. You can use a coin, die spinner, or whichever you think is relevant. Just don't spend too long. Don't have trials of over 100, we'd say. Try and keep it simple enough.